All right, and welcome everyone to Oceanside Library's online program, Extreme Weather on Long Island. Today's lecture will be presented by Jase Bernhardt, Assistant Professor at Hofstra University. Thank you for joining us today, Jase, and take it away.
All right, thanks for having me. As mentioned, my name is Jase Bernhardt. I'm an Assistant Professor at Hofstra University. I'm in the Department of Geology, Environment, and Sustainability there, and I'm the person who gets to teach classes in meteorology and climate. And today I'm going to speak about some types of extreme weather that we face on Long Island. And of course, the opening slide here shows a picture of one of the types of severe weather that we face, of course, thunderstorms, taken from Hofstra's campus about a year or so ago. So today we're going to talk about first a bit on some of the recent interesting weather that's been happening, specifically this morning, actually. And then we'll talk about three different types of extreme weather events that impact Long Island: East Coast winter storms, thunderstorms, and tropical cyclones or hurricanes. Then we'll quickly talk about the short-term weather outlook for the coming days and next couple of weeks, since it is a weather lecture. May as well talk a little bit about the weather, and then I'll be happy to take any questions that come up.
Hey, Jase, I don't know if you know, it's not on slideshow view, but I don't know if you want it that way.
Yeah, I'll pop it on the slideshow in a minute.
Gotcha.
Thanks. Just so I can see, I'm going to ask for a chat here early on, and then I'll go to the full view. So yeah, so the first sort of interesting update is something that's actually happening today is officially the Atlantic Ocean hurricane season begins on June 1st, so just a few days, but the hurricane season is not totally constrictive, so you can still have storms forming both before and after the hurricane season. It runs June 1st to the end of November each year, but there can be storms that form before the official start, and that's what's happened here this year. A few weeks ago, we had a weak tropical storm Arthur that formed, and this morning we had a weak tropical storm Bertha that formed, and that actually made a landfall in South Carolina around 9:30 this morning and relatively weak, but the winds are around 50 miles per hour, so there's some gusty winds, storms, and very heavy rain. There's some flooding concerns for the Carolinas up into Virginia, actually, for today and tonight, with some very heavy rain falling there. And that's sort of a classic early season tropical system, fairly weak, short-lived, not much wind, but they can bring heavy rain and flooding, which can lead to property damage and plenty of issues. And the way hurricane naming works is that each hurricane season is a list of names to use. And you'll note from the slide here, they start with each letter of the alphabet, just skipping a few of the less common letters, like there's no Q, for example, because there's just not that many Q names out there. And you also note that it alternates male, female. So this year there's a male name first, Arthur, then a female named Bertha, then back from a male named Cristobal, and then a female named Dolly, and so on and so forth. So we've gone through Arthur and Bertha. Whenever the next storm forms, it's going to be a C name. And as I mentioned, hurricane season officially starts June 1st, but you sometimes do get storms before the official start of the season. And that's happened a handful of times before, most recently in 2012. And a little bit more on the hurricane naming convention, since it's of interest to some folks. These lists recycle every 6 years. So basically, this list for this year is used back in 2014, and it'll be used again in 2026. So there's essentially 6 of these lists that then rotate. However, a particularly strong or damaging or deadly storm, its name will be retired, and then a new name will come into place. So, for example, on this list, Hurricane Ike back in 2008 was a very strong storm that impacted Houston, Texas. So that name got retired. Now we have Isaias as the name on the list now. And closer to home, of course, Sandy in 2012, that name, of course, was retired because it brought devastation to a big part of the Northeast US. So that's a bit on how the hurricane naming works. One more thing, we do rotate the male and female names through a year. Then also year to year, we sort of switch which one starts first. So this year, male name started first, Arthur, and then next year, a female name will start first. And this hurricane naming convention has been around for about 40 years, having the alternating male and female names. Before that, they were naming storms for a few decades, and incidentally enough, it turns out that, well, now, but especially back several decades ago, most meteorologists were male-dominated field. And at first, when they first started naming hurricanes in the mid-20th century, they were all named female names, since sort of maybe the males were all writing the names, so they didn't want to associate it with the males. So anyways, hurricanes used to be female names only, and about 40 years ago, to make it more equal, they started the present system where it goes off and on, male and female names. So that's a bit about how these hurricanes get their names. It's not random. It's actually a very specific system. And moreover, the names are going to reflect sort of the cultures of the areas that get hit by the hurricane in the particular ocean. So, for example, the Atlantic Ocean hurricanes hit the U.S. and also Central America and the Caribbean. So you have a mix of names from the more American lexicon and the more Latin American lexicon, because both those areas get impacted by these storms. Different parts of the world will then have names based on the different cultures being impacted. Here's, again, what happened this morning. We had this tropical storm Bertha making landfall. Here's a radar picture on the left here from earlier. And you see the dark greens and oranges, very heavy rain. So flooding concerns in the Carolinas, that'll spread up into the Appalachians tonight. And then here's a satellite picture. So the picture matters space of basically the cloud top temperature, so where the really high cold clouds are, indicative of a strong storm. So the deep reds here, sort of the center of the hurricane making, or a tropical storm making landfall. So rather weak, but we do have a tropical system in Bertha. Right. So I want to quickly say, okay, well, which types of extreme weather seem most important for Long Island? So feel free to chat into the box now or at any time what you think the most important forms of weather are that impact Long Island. I'll talk about 3 of them in this lecture here, but if you have questions or thoughts about other types of extreme weather, I'm happy to discuss it a bit at the end of the lecture or ask specific questions. So feel free to chat in if you think I'm missing something or want to learn more about something else. But the 3 we'll be talking about today are going to be winter storms, thunderstorms, and tropical cyclones. So first, let's talk a bit about sorry, something happened here when I minimize. All right, go back to presentation. All right, sorry about that. So yeah, today we're going to talk first about East Coast winter storms. So yes, and we will talk about hurricanes here. So yeah, first East Coast winter storms, sort of look back on winter first, and then talk about thunderstorms and tropical cyclones, because that's sort of the season we're getting into. Thunderstorms sort of in the summer are biggest on Long Island, and tropical cyclones, their biggest start to Long Island is late summer into the fall. So we're roughly going through sort of chronologically through the year here, sort of when we expect the different types of extreme weather events. All right, East Coast winter storms, without further ado. So East Coast winter storms have some different names. You may have heard them referred to as nor'easters or coastal storms or something else, blizzards. The definitions vary, but there's some unifying factors of most of these coastal storms that strike us on Long Island. They occur most frequently October through April, so the winter months, maybe late fall into early spring, they can still impact us. And they're most frequent during the winter, December through March. There's some different meteorological characteristics that define these storms. We want it to be a low pressure system or a cyclone. You have low and high pressure systems, those L's and H's you might see on the weather map. High pressure H is the boring weather to meteorologists. It's clear, calm conditions. Today, for example, high pressure is dominating the Northeast US. And the low pressure is unsettled weather. So that's when you have clouds and rain, storms, those sorts of things. So wintertime low pressure systems are these East Coast winter storms. They're generally going to move along the coast of the Northeast. The satellite loop here showing clouds. Notice how that sort of comma-shaped low pressure system is moving southwest and northeast, so vertically up and to the right. So typically we see these storms paralleling the east coast of the US and pushing back into Long Island strong winds, heavy precipitation, which could be rain, it could be snow, it could be in between, like ice or sleet. And coastal flooding is actually a big part of these storms as well. Since they're pretty big, powerful storms with lots of wind, they can kick up high waves and rough surf, and that can lead to coastal flooding and beach erosion and storm surge at times. And sometimes these storms can rapidly strengthen. That's a so-called bomb cyclone, which is actually an old school meteorological term from many decades ago, but the media got a hold of it a few years ago. And you might have heard bomb storm or bomb cyclone circulating around in the media. That's just a storm that rapidly intensifies. And this happens actually off the East Coast, off Long Island sometimes, because you have a feature called the Gulf Stream, a very warm ocean current, just off the east coast of the US Atlantic Ocean. So what happens is during the winter, you can sometimes get very cold air coming down from Canada into the Northeast US and then over the Atlantic Ocean. And that very cold air from Canada, polar air, mixes with the much warmer ocean water from the Gulf Stream, and that can sort of spin up a strong coastal winter storm. So the physical geography of the eastern US and western Atlantic Ocean makes these storms occur, and often several of them occur each winter. So what are the big impacts from the East Coast winter storms? To recap, heavy precipitation, could be lots of snow, but not always snow, sometimes heavy rain or in between. So flooding can come from the heavy precipitation, freshwater flooding, or inland rivers and lakes and streams can flood. And then wind can sometimes be severe from these storms, but often most impactful on Long Island is the bolded in thing here. Coastal flooding and beach erosion. So these winter storms can actually lead to some coastal issues for us on Long Island, especially low-lying areas like the South Shore, like Oceanside, especially parts of Oceanside getting down towards, Island Park or Long Beach, places like that, Baldwin. As you go further south towards the shore, of course, you're in a lower-lying area closer to the bay and even the ocean, and the water from those sources can get pushed in by the strong winds and surge from the storm. And that can often trigger warnings, watches, and advisories being issued by the National Weather Service, which has an office. It's the New York office of the National Weather Service is actually located out in Suffolk County at Brookhaven National Lab, which is way out in Upton, Brookhaven, Suffolk. So whenever you get maybe like a text message on your phone about a weather warning, or you see a crawl on the bottom of the TV screen about a weather warning, or you see a highway sign flashing with a weather warning, all that is being issued by our local National Weather Service office for New York. So what are some of the warnings that we can see as part of winter storms? Well, we get winter weather warnings that deal with winter precipitation. So if we're expecting only 6 inches of snow on Long Island from especially a coastal storm, we'll have a so-called winter storm warning being put in place. That means it's a pretty sure bet that within the next day, if not sooner, if not imminently, there's going to be significant impacts from winter precipitation, and generally that's going to be a lot of snow. A winter storm watch is saying there's a possibility of those conditions in the next few days. We're not totally sure yet. So there's that sort of saying, watch out, and then warning is okay, definitely this is going to happen. Unfortunately, the winter storm warning sounds a bit confusing. So winter storm warning is sort of the most severe. Winter weather advisory, so advisory is not as strict as a warning. A warning is really you should avoid traveling at all costs. There's going to be snow days and events canceled because, as you know, if there's 6 inches or more of snow on Long Island, that's going to make the roads really bad. And you really don't want to go out unless you absolutely have to. Winter weather advisory means usually it's about 3 inches of snow. So that more moderate type of storm, 3 to 6 inches of snow, or sometimes maybe only an inch or two of snow, but there's some ice or sleet on top. So winter weather advisory means still avoid travel, if at all possible, but there's a little more leeway if you have to go out. It's not going to be quite as severe. And then perhaps the most impactful type of winter storm is a so-called blizzard. And a blizzard has to do with not only snow, but also visibility and wind. So we get blizzard conditions occasionally on Long Island, maybe once every few winters. And a blizzard warning will be issued if blizzard conditions are expected to occur. A blizzard means that you have snow either falling or getting blown by the wind. Typically it's been falling on the sky on Long Island. So we have snow falling, probably heavy. But the key thing is you have winds of at least 35 miles per hour. So those strong winds blow the snow around and create whiteout conditions or very, very low visibility. And if you've been a long time Long Island resident, I know that you've experienced this before. When you have that heavy snow falling and the wind's blowing it and you can barely see. Visibility is going to be a quarter of a mile or less, sometimes much, much less. Sometimes you can look out your window and barely see across the street. The visibility is so low, you can maybe only see a few houses down. Obviously, that is the most impactful winter travel conditions, because if you can't see more than a quarter of a mile, trying to drive around the parkways and busy roads of Long Island is, of course, impossible in those conditions. So there's a blizzard warning, really it's a severe impact. So travel is basically stopped. And of course, things like flights are stopped as well. You can not fly a plane into JFK or LaGuardia when the visibility is so low. So those are different terms you hear for winter related conditions. Another big impact from the East Coast winter storms, in addition to that precipitation, is going to be the coastal flooding. So a lot of our coastal flooding on Long Island actually comes from winter storms. There's usually at least a few winter storms per year that give us some flooding along the immediate South Shore and barrier islands of Long Island. And again, this is because these winter storms are large and strong, and they have winds that are considerable, and they push in lots of water, waves and storm surge. So this water gets pushed in by the strong winds of the storm. Now, if the storm happens to line with a high tide, or maybe impact over multiple tidal cycles, then you can really see significant impacts in terms of flooding in immediate coastal areas. So that means we have to look at a lot of different aspects of these East Coast winter storms. The speed is very important. Not obviously, the stronger the storm, the more surge it can create, but also the track and the speed are very important. If it tracks sort of just the right way, it can really angle in, push in lots of water into our bays of the southern shore of Long Island, which can then lead to flooding. And the speed is actually bad if they move slowly, because that leads to a longer impact of the flooding. So again, if they extend over multiple tidal cycles, that can be a problem. And a couple of Marches ago, March 2017, there was a coastal storm, East Coast winter storm. It was actually supposed to be a lot of snow, but then the snow changed to sleet. So we didn't get a lot of snow accumulation. So some people called it a bust, but we ended up having about 3 feet of storm surge along parts of Long Island. So 3 feet of water came in. So even though the snow wasn't big, low-lying coastal areas got significant flooding. So it shows that these winter storms are multifaceted. It's not just the snow, despite people obsessing over the snow amount. It can also be the wind, and in many cases, the flooding. So, as I mentioned, storm surge is going to mainly come from winter storms around Long Island. Though, of course, tropical cyclones, hurricanes can bring some of the surge as well. And if you're a long-time Long Island resident, this list might look a bit familiar to you. This is a list of the top 20 storm surges of all time for Montauk, way out on the east end. So again, storm surge is extra water above the normal tidal level. So high tide's a certain number of feet, then how many feet of extra water comes in at high tide due to the winds of storms pushing in big waves. That's the storm surge. So here's the top 20 biggest storm surges of all time for Long Island. And number 1 here, and feel free to chat in if you maybe recognize any of these dates as famous storms. Number 2, for example, is surely fresh in a lot of our minds. So number 1, 1954, that's actually Hurricane Carol from 1954. So in the 50s and 60s, there were a few hurricanes that struck Long Island pretty directly, and Carol was one of them. And that was number 1 in 1954, August 1954. So the speed above mean low level water, essentially this means that there's over 8 feet of extra water coming in to Montauk there. So extreme amount of flooding, of course, we had 8 feet of water coming in to places like the South Shore, which is very low lying, not much elevation, of course. Then 2012, October 29th, of course, that's Sandy. So Sandy brought the second largest surge of all time. But then we see mostly winter storms dominating the list. So what essentially happens is hurricanes can bring really high surge levels, but there's not that many of them. More consistently, we have high surges from winter storms because there's many of them in a given year. So number 2, Sandy. Number 3, February 78. Some of you might remember the blizzard of 78. It was one of the biggest storms for New York. In the 20th century, that was the 3rd biggest surge. This next one here, October 1991, that was a so-called perfect storm. There's actually a famous book and movie about it. And that was sort of a hybrid, like Sandy, sort of a hybrid of a winter storm and a hurricane. Then we see more winter storms, these November storms here, 50, 53, and 68. And in 72, a winter storm. December 92, a winter storm. December 2010, a little bit more recent. You might remember that one about 10 years ago. And that was a big post-Christmas storm of 2010. About 20 inches of snow fell in New York City. That brought a lot of surge. And again, we see mostly winter storms on this list, with just a few tropical systems mixed in. 2011 here, August, that's Hurricane Irene, which of course impacted Long Island with a significant amount of surge. So the point is, most of the biggest storm surges, the most flooding and storm surge comes from winter storms, as this list reveals. One other way we can sometimes get a lot of snow quickly and low visibility is called a snow squall. These are not very frequent on Long Island. They occur every few years, but when they do occur, they can lead to big issues. So a snow squall is a sudden, brief burst of very heavy snow and wind, which leads to so-called whiteout conditions. The problem with snow squalls is they can occur suddenly. It can be sunny out, and then 5 minutes later, you have heavy snow and strong winds. It almost feels like a blizzard that just comes on suddenly. And as you can imagine, this can lead to big traffic issues. And that's because people are just driving along like normal on Southern State Parkway, and all of a sudden you can't see. And then you end up having a big issue with traffic and collisions and people slowing down. And the problem is, until recently, there's never really much in the way of warnings for these. So just last year, they started up the snow squall warnings in the National Weather Service. So now you can get a warning for a snow squall, which is, again, a sudden brief burst of snow. Here's a video of what a snow squall looks like. This is from a roof of my building at Hofstra. Notice I can barely see at all. You can barely see maybe even an eighth of a mile. And again, this, within 5 minutes, it went from sunny to that, and then back to sunny again. The problem is people are lulled into a false sense of security with a snow squall. They think it's fine, and then all of a sudden, there's this really bad snow that comes. So there's been a lot of effort lately to have warnings about these, because when they do occur, they can lead to big issues. Don't want to see that again. Okay, so that's our winter severe weather. Now let's next talk about thunderstorms. Of course, more appropriate to the time of year. Thunderstorms are continually occurring in Earth's atmosphere. They're made up of very tall, vertically rising clouds called cumulonimbus. Sometimes you see the puffy, sort of fair weather clouds like cauliflower or something. Those are cumulus. When they start rising even higher, towering up, those are called cumulonimbus. When you see those big towering storm clouds, that's often a sign there could be some heavy rain and storms and rough weather coming through. Thunderstorms are really important globally for redistributing heat and moisture across the world. So they're very important to sort of making the world's weather system work. But of course, they unfortunately can bring along some damaging features. So as I mentioned, warnings are issued by the National Weather Service for severe weather. And there's certain criteria that if a thunderstorm meets it, there's a warning issued for a thunderstorm. And again, that's going to go through your TV call or the radio or text it to your phone or on the highway sign. To trigger a warning for a severe thunderstorm, it has to have one of the following things, at least one of the following things. Wind gusts of at least 58 miles per hour, winds that strong or stronger can lead to significant damage, like large tree branches coming down, power lines coming down. A tornado, that's of course a severe thunderstorm if it's causing a tornado, or if it produces hail of at least 1 inch in diameter. So hail 1 inch across, and to sort of conceptualize that, this picture here, figure a quarter. So hail the size of a quarter or bigger, that's going to be considered severe hail. And hail that large can can cause some damage, denting of cars and things like that. So if a thunderstorm has any one of these things, it will be considered severe. Important to note that even if it's not severe, a storm can still be dangerous. For example, lots of lightning can occur with a storm. Even if it's not severe, that can still be dangerous to humans. Or heavy rain can occur with a thunderstorm. That might trigger a flash flood warning or a warning for very quick flooding that might occur when a storm is dumping lots of rain. And Long Island has this issue a lot with the flash flooding. And I'm sure you've all experienced before when there's a lot of heavy rain in the storm, all of a sudden parking lots and sidewalks might flood. And that can certainly be a nuisance because we have poor drainage here with all the development we've done. How do we get severe storms? You need moisture source. So warm ocean water in the Gulf of Mexico or southwestern Atlantic can provide the moisture. Basically, the warm ocean water is evaporated up into clouds into the water cycle, falls back down as heavy rain. You want an unstable atmosphere. That just means the air is rising a lot. You have what's called convection. Think about like water bubbling in a pot of water that you're boiling. Same concept in the atmosphere. When you have convection, you have lots of rising air. That creates clouds and thunderstorms. And hot and humid air is especially unstable. You probably heard the adage that warm air rises. Warmer air and humid air is lighter, so that allows it to rise more easily, create this convection, create these storms. And you prefer what's called a lifting mechanism, something to really give that air an extra push to rise upward into clouds. That could be a weather front, which is a boundary between air masses, mountains, obviously not around Long Island, but in other parts of the world. And to get tornadoes, to get your storm spinning around, that's called a supercell storm, a thunderstorm that's rotating around. You want what's called vertical wind shear. That just means the wind speed and direction changes with height. Sort of think about it. If the wind direction changes with height, that can get your storm clouds spinning around, which can sometimes pop out a tornado. Fortunately for us, tornadoes are very uncommon on Long Island, but on rare occasions they can occur. So here's a bit on our climatology, or what the average conditions are for storms around the New York City area and Long Island. A couple graphs here that I'll try to explain briefly. On the right here, we have a map showing just a 25-year period, showing all the severe weather reports. So the dots are either reports of wind or hail that was severe. Again, severe wind, at least 58 miles per hour. Severe hail, that was at least 1 inch or quarter size. And the red lines are tornadoes. So notice during this period, no tornadoes in New York City or Long Island. So they're very uncommon. They do occur occasionally. But we do occasionally see hail and winds from storms. But notice the relative paucity, relative minimum number of storms over Long Island. Oh, as it turns out, Long Island's surrounded by water, the Atlantic Ocean, Long Island Sound. And that water is cool during the summer. As you all know, the ocean's cooler during the summer than the air usually is. So that cool ocean water leads to a more stable atmosphere. The air is cooler, so it doesn't rise as easily. It's not as light. So that just sort of insulates us. Oftentimes we see lots of thunderstorms coming in from the west, from the inland part of the US, and they often weaken as they hit Long Island. And this map really shows that, because you can see there's far fewer dots on Long Island, especially in Suffolk County, the eastern part of Long Island, than if you go inland into New Jersey and into upstate New York. So Long Island actually gets fewer storms in surrounding areas because the ocean tends to stabilize things a bit. So that's good, fewer storms, but sometimes that can be an issue like a gardener, because sometimes we see this nice heavy rain coming towards us and sort of fizzles out. And like July, August, when it's dry, you actually want that rain, but it doesn't always materialize. When do storms occur? Well, this shows the average timing. And basically, this is a universal time here, this graph, so a little bit confusing. But essentially, the storms are occurring. So this is just 4 hours ahead, and it's in 24-hour time. So this peak here, the 2021, that's 4, 5, 6 o'clock. So 4, 5, 6, 7 o'clock, late afternoon, early evening, that's when storms are at their peak for our area in terms of the daily timing. And then in terms of the seasonal timing, here's the months. So notice how really it's May when we start seeing storms. We see one peak around this time of year in the spring, and then another peak during the summer. So late June, July, and August. When it's generally on Long Island, when it's hottest and most humid, that's the best chance of having storms, especially the first half of the summer, late spring and early summer. Things start to fall off as we get later into August and into the fall. There's fewer storms. But technically, storms can occur really any time of year. They're just going to be most frequent during the late spring and first part of the summer. Here's a quick look at a thunderstorm time-lapse video. And this is from Hofstra's campus. You might recognize, of course, here's the Hempstead Turnpike in the Uniondale Hempstead boundary here. So here's a thunderstorm coming through. So here's a time lapse. Notice the traffic. You'll see the clouds are going to thicken and get darker. Here comes the storm. Notice the big push of wind with the storm. That's called a gust front. Basically, there's a big push of wind sometimes right before a storm. And then we see the heavy rain, of course, occurring with the thunderstorm. Not a severe storm, but a nice storm. I'll play through the time lapse one more time. Again, pretty clear. Then there's going to be a big gust of wind. That's sort of the initial push of wind from out front of the storm. Then it just gets generally windy, and then we'll see the rain start and some small hail, lightning, and thunder. So a typical thunderstorm. Usually we don't get the severe storms, but we do get some heavy rain and lightning on occasion from thunderstorms. Oh, all right. And now, last but not least, let's talk about tropical cyclones, hurricanes, which of course is on our minds right now. As I mentioned, we're seeing a tropical storm impacting the southeastern United States today. And of course, we're getting into hurricane season where we have to pay attention to these sorts of things. So, tropical cyclones. As meteorologists like to use the term tropical cyclone because they're actually called different things across the world. So they're called hurricanes in the Atlantic and Eastern Pacific Ocean. But other parts of the world have different names. For example, you might have heard the word typhoon before. That's tropical cyclone in the Western Pacific Ocean. So those can impact Japan, and Taiwan, and China, Korea. And then in the Indian Ocean, they're called cyclones. We just had a cyclone actually impact India and Bangladesh. In those places, Australia can get cyclones. So it's the same storm, typhoon, hurricane, cyclone, same thing, but just different regional names. So sort of more broad, we often just call them tropical cyclones. So they're known as hurricanes, again, the Atlantic and the eastern half of the Pacific Ocean. So they're low pressure systems. They're large rotating cyclones, or low pressure systems. It turns out hurricanes can only form under a very specific set of conditions. You want very warm and deep ocean water. So ocean water of at least 80 degrees Fahrenheit or so is a general cutoff. That ocean water also has to extend down a bit because a hurricane is strong enough to actually churn up water from down below. So if the water just below the surface is very cold, the hurricane churns it up and it weakens itself. So you want that water to be warm at the surface of the ocean and extend down at least a few hundred feet. Hurricanes actually want low wind shear. You don't want a change in direction and speed of the winds with height in the atmosphere. Hurricane sort of makes its own circulation, so you don't want the overall atmospheric circulation to ruin it. And then you have to be a little bit away from the equator. Once you get away from the equator, you have the so-called Coriolis effect, the Coriolis spin taking effect over large distance changes. That just basically means you get a spin in the atmosphere due to the way the Earth rotates and that the Earth radius changes from its peak at the equator to a lower radius at the poles. So long story short, you want to be at least 5 degrees away from the equator to get that spin imparted onto your storms. So that means hurricanes typically form between about 5 degrees north latitude and about 25 degrees latitude north or south of the equator. That's where you're away from the equator to get the spin. The ocean water is warm enough. And then when you have conditions right, like the low wind shear, you can get the hurricane starting to form. Hurricanes then, of course, can sometimes move to areas outside of the tropics, like Sandy, for example. So hurricane season starts June 1 technically. Usually starts off pretty slow. June, July are pretty quiet. And in July, most of the hurricanes that form in the Atlantic Ocean are going to be where the water is warmest. And the water is warmest first over the Gulf Stream, over the Gulf of Mexico, and over the Caribbean Sea. So these blue areas here are where you have most storms forming early in hurricane season. Our first two storms this year, Arthur and Bertha, which did form early, but they formed in these blue areas. As we get towards September, notice how this is a much brighter diagram, more color. So that means storms are much more likely to occur. September is actually the peak of hurricane season. And during this time, storms still form in those places. They can also form across the central part of the Atlantic Ocean. Sometimes storms form off the African coast, track across the Atlantic Ocean, and sometimes hit the Caribbean, sometimes they hit the Gulf of Mexico, the eastern US, or sometimes they even just turn out in the open ocean and never really impact any land masses, which is of course the ideal situation. So what impacts hurricanes bring? They bring a lot. They can of course bring storm surge and flooding and waves, strong winds, heavy rain falling from the sky, and then infrastructural issues. For Long Island, we often most pay attention to 1 and 3 here. So the storm surge and waves can be very significant for Long Island, even in a weakening storm like Sandy was. And then heavy rain sometimes can be a big issue, especially when the storms sort of move slowly and make their way up the East Coast from further south. So storm surge can be a big deal for Long Island from storms. Again, Sandy was a typical example of this. The right side or east side of a storm is going to be worse for surge in the northern hemisphere in a hurricane. That's because you have winds rotating in a so-called counterclockwise fashion around a hurricane in the northern hemisphere. So think of an analog clock, and the way the clock hands move, winds are going to move the opposite way, the opposite type of rotation around hurricane northern hemisphere. That means as the hurricane's approaching shore to make landfall, the right or east side of the hurricane, that is going to be where you have the winds pushing from the ocean, from the water into the land. The strong hurricane winds push the ocean water into the land. And that's what happened in Sandy. We were to the northeast of where Sandy hit, technically hit around Cape May, New Jersey. We are northeast of that. So the large circulation around Sandy pushed in all the water straight into New York Harbor, straight into the Great South Bay, straight into Long Beach and Barrier Islands, Fire Island, all those places, Jones Beach. And that's why we got the devastating surge from Sandy in New York and Long Island. So it's mainly the hurricane just whipping up the ocean water and pushing it into the land. Also, there's a bit of the so-called barometric effect. Hurricanes are very low pressure, so when there's less pressure on the water, it rises up a bit. But it's more just the push from wind. And of course, when storm surge hits with high tide, that's going to be even worse because then already naturally the water level is higher, and the storm surge on top of that can bring in a lot of water. And unfortunately, that's what happened with Sandy. Sandy is a worst case scenario for surge for Long Island because it hit during a high tide and a higher tide than normal due to the moon position with the Earth. And then, of course, Sandy was a very large storm, a once powerful storm, still was strong when it hit the northeast US. So it kicked up a huge amount of storm surge and led to the flooding. And also, as in the last point here, Long Island is especially vulnerable to flooding from storm surge because you have shallow bays and things where the water can really pile up and push inland, and there's nothing to stop it. Some images from Sandy storm surge. There's one of the tunnels in New York City flooded. There's Long Beach, of course, flooded from both sides. Water came from the south side, from the Atlantic Ocean, from the north side, from the bay, met in the middle of Long Beach Island. Obviously, a very devastating situation. And even the mainland part of Long Island, so to speak. Here's a look at the Bay Park Power Plant around East Rockaway. 10.9 feet of surge flooded that plant and, of course, knocked it out. Tropical cyclones are actually peak in the average year in early September. September 10th is the average peak of the season. Why is that? It turns out ocean waters are delayed in warming up. It takes longer to heat up water than land. So the land sort of peaks in temperature in late July, usually in the northeast US. But the oceans don't peak in temperature late August and early September. Therefore, you get the most hurricanes in early September typically because that's when the ocean waters are the warmest. And warm ocean water is the food essentially for hurricanes. It helps to fuel them and strengthen them. Here's a map of some of the past continental United States hurricane strikes. So you'll note the most hurricanes hit from the Outer Banks, North Carolina, and all the way around towards Texas. Hurricanes are split into different categories. The stronger the winds, the higher the category. And notice how there's a relationship where there's fewer of the stronger storms than one might expect. So the black and reds, for example, the category 4 and 5 hurricanes, notice how there's very few of those landfalls. In category 3, there's not so many either, the blue. 3, 4, and 5, those categories are so-called major hurricanes. Those are the ones that really bring damage, devastation when they strike the landmass. So you see, of course, southeast U.S., lots of hurricane landfalls. Notice the secondary peak right on top of us in Long Island. And that's because notice how we start to stick out. We stick out east, Long Island and New England. So hurricanes sometimes sort of are moving north and east, away from the U.S., but sometimes sort of sideswipe Long Island on their way up. So the fact that we stick out to the east sort of puts us in the path of hurricanes sometimes. So here's our Long Island landfalls of recent vintage. Again, Carol 1954 and Donna 1960 and Gloria in 85. Those are the 3 hurricanes that have made landfall in Long Island in the most recent several decades. Of course, before this, we had the Hurricane of 38, the Long Island Express, which brought extreme amounts of damage. It's one of the strongest hurricanes probably to ever hit Long Island in many centuries. And then, of course, there's Sandy in 2012 hitting southern New Jersey. But as I mentioned, counterclockwise flow, like the way I'm moving my mouse arrow, you can see it. Anyways, Sandy being northeast of Sandy meant that it pushed in lots of water, lots of surge straight into Long Island, New York City. All right, so that's what happens in terms of extreme weather. As I mentioned at the top, I'd be remiss not to talk quickly about the crystal ball for what's the weather look like in the future here. So just quick on the short-term trends and slightly long-term trends. So we're looking muggier and stormier in the next few days. And actually Bertha, that tropical storm that's in the Carolinas right now, is actually part of the cause of that. Bertha's going to move to our west, but that counterclockwise flow, that's going to drag in muggy air, moist air from the Atlantic Ocean. So it's going to start turning muggier, and there'll be some showers and isolated storms coming up later this week. That's courtesy of Bertha. Then though, it'll really turn pretty nice, cooler and drier. So here's some map projections for 6 to 10 days, 8 to 14 days from now, so next week or two. Basically, the blue, the B says low normal temperatures expected, the map on the right for the eastern U.S. And the B here says low normal precipitation. So it looks like cool and dry for the next week or two after we get through the late week and Saturday. So that's good for this time of year, because in June that means 70s and low humidity and sun, which I suspect most people are fans of. So it looks like after we get through the latter part of this week, a nice stretch coming up for next week. So that's your quick little look at the weather coming up. Even further in the future, so hurricane season has already gotten off to a quick start. There was 2 very weak storms that formed, but the forecast calls for an above average, an active hurricane season. So for example, in a normal season, we expect about 6.5 hurricanes. This forecast from Colorado State University, which is one of the leading forecasters for hurricanes, is saying 8 hurricanes in the Atlantic Ocean this year. So above normal is expected. Named storms, once you're a tropical storm, 40-mile-per-hour winds or more, you're a named storm. You get one of those names on the list. Normal is about 12, the normal average. Forecast for 16. So really all these metrics here are different ways of saying that we're expecting more hurricane activity than normal this year. Doesn't mean there's going to be hurricanes hitting the U.S., but as you expect, the more hurricanes are, the better chance one or more will hit the U.S. And who knows, maybe we'll even see impacts from one on Long Island. Any hurricane season, there could always be a hurricane hit us on Long Island. It's a low probability, but it's not 0. So especially if you're in a lower lying area closer to the ocean, and a lot of Oceanside fits into that category, coming into any hurricane season, you should have your plan ready. You know, what do I do in case I need to leave or take protective actions? You should have that plan in place well in advance, because as we know, right before something happens, things get crazy. So always coming into hurricane season, so like now is the time before it really gets going. You want to have a plan in place, be stocked up with some extra supplies just in case. Because all it takes is one. And obviously an active hurricane season is a better chance of one hitting, but even a not very busy hurricane season, you could still get that one storm that forms could come and hit Long Island. So you always want to be prepared, but this year especially you want to be watching carefully, because it is expected to be a bit more active than normal. And last but not last, but certainly not least, just a minute or two on the research I do. So we are working to improve weather warning communication at Hofstra, and we've been using new technologies such as virtual reality and interactive video games to help people experience what a hurricane looks like without actually being in one. As you can imagine, this works great for especially younger generations, so college students, high school students, and elementary age students. So I've gone to several local schools and civic organizations to talk about hurricanes like this. And then when I'm in person, I can actually show the virtual reality, which again is a great engaging way to demonstrate what a hurricane looks like. Hopefully help people understand, here's what it looks like in a storm, so what do I need to do to be prepared? So that's all for my talk. Thank you for your time and attention. If you want to ask, feel free to ask questions. And also there's my contact info if you want to contact me for any reason. So I hope this is interesting. We covered a lot. And again, if you have any questions or comments, I'm happy to take them here in the last few minutes of our talk today. Thank you.